Hi everyone, welcome to the Solar Power Market Series. My name is Erez Dolev and I'm the Managing Director at Renvu. Today we are going to be hearing from Greg Smith, the author of the bestseller The Battery Powered Home and the Technical Training Director at Tigo Energy. Greg is one of the most knowledgeable people when it comes to energy storage, and with his presenting skills, I'm sure we will all enjoy it. This is our third webinar with Greg, and this time he will go in depth into ESS terminology, basic electrical setup of a complete ESS and how it interconnects with the home, lithium chemistry overview, a brief overview of AGM batteries, and understanding battery bank sizes. Before we dive in, and while we are waiting for more people to join, I'll give a little background on Renvu and some of the products and services we offer. Renvu is a US-based solar equipment distributor. The company was founded in 2012 and has fulfillment facilities in California, New Jersey, and Texas. Our leading energy storage solution is the SolarArc 12K all-in-one inverter combined with a low voltage power battery bank from Fortress Power. We also carry several high voltage batteries and inverters like the Growatt inverters and battery banks, and the Solis inverters combined with the BYD battery banks. For panels, we have on the shelf multiple options such as Canadian Solar 380, 385, 390, all black, Q-Cells 480 watt, Q-Cells 340 all black, Hyundai 390, Recom 380, and we have a container of Longi 450 coming in the next 2 weeks. We're sharing in the chat a link to our commercial price list, which includes pricing of solar panels. You can see here some characteristics of the panels, the availability, how many we have, and when it comes, if it's not on the shelf, and pricing for different quantities, and link to the data sheet, and also a date, the last date that we updated this row. There is also a sheet over there, or a tab that includes ESS or storage with inverters and batteries with several characteristics and prices, so you can compare different options and choose the best option for the specific installation. I'd like to show you the Bleaky residential carport real quick. This is a great way to expand existing solar systems, or alternative solution where you cannot install solar on the roof. This is a 2-car carport with option for 1 car or tandem carport with shared columns, so you can connect both 2 or more carports like these. It doesn't require heavy tools to install it. Even the footing is designed for only 2 feet deep. The kit arrives on 2 pallets, and installation process is really quick. It comes galvanized and painted with first layer of marine grade paint, and you can paint a second layer to hide all blemishes that happen during shipment or installation. This is a solar structure, so it's eligible for the extended 26% ITC, accepts any panel or inverter that you prefer. The carport is supplied with the iron reach system and under clamps. When combined with a Bleakier EPDM T-gasket, the surface becomes watertight, and there are several other accessories like mesh that you can hide the electronics below, safety lights that you can add, EV chargers. It's designed and fabricated in Texas and comes with 25-year warranty. The structure is coming with a structural engineer, a PE stamp, mainly for California, for Texas, sorry. And there is a possibility to purchase PE stamp for other states if needed. With basic load capacities of 35 pound per square foot of snow load, can be upgraded to 65 pound per square foot, and with 175 miles per hour wind load and seismic design category E. The 2-car carport is 18 feet wide and 18 feet deep with 9.5 feet clearance. It comes with a 5-degree tilt. Okay, you can find a 3D model of the tandem carport. This is the tandem you see sharing columns in order to connect several of them, or the standalone carport on the Blicker website. We will share it. We'll share a link to that in the chat right now. The last part I want to go over is our online quote tool. You can find it on our homepage, and it's very easy to go through and generate a formal quote in up to 2 minutes for any type of inverter, mounting type, or racking. On the left side, you will see your bill of materials building up and prices changing as you change products. If you're logged in, the prices will show up. If not, you will see only quantities, the way you see it here. This is the racking or installation page. I chose roof and metal type, number of arrays that I want to install. So the first array, I'll put 3 rows on that array, 5 modules in the first row in landscape, and then the 2 next rows will be in portrait. Okay, second array. And then you get to choose the brand of racking that you want, the brand of roof attachment, rail color, clamp color, the span that you want of the roof attachments. And you will see the prices changing on the left as you do that. Have a little sketch here. Then, do you want energy storage or not? If you do want, you will get options for inverters that will give you that option. So in this case, I will choose the Solarc 12K type of battery that you want, and also you put here the minimal kilowatt battery capacity that you're looking for. I type in 15. I'm getting these options, and it will give me the number of batteries that I need in order to get to that. Additional items. This is rapid shutdown that I want. I need a rapid shutdown for the system. This is the balance of system. I will choose EV chargers to this, and monitoring and full permitting package. You can remove or add anything. Then you can click on that button to generate a quote and send it to you by email. There's a disclaimer when you're connected or when you're logged in. If not, you put your email and then it will send this quote to your email. In this case, it generated a proposal. This is a formal proposal that you can interact with our sales team on, and you will have a copy in your email, but also this is what you see under your My Account. Okay. If you have any questions about these products or while Greg is presenting, please feel free to ask in the Q&A section, not in the chat. It will be much easier for us to filter through the questions and answer. We'll go at the end of the webinar. During the Q&A session, we'll go over these questions, and if something will be relevant, I will interrupt Greg in the middle of the presentation and ask that question for you. If you can also email our sales team at info@renvu.com for more information and pricing. As well, we do have recordings of previous webinars on the Renvu YouTube channel. If you want to take a look at any of our past webinars offerings, we will share a link in the chat for that. This webinar is being recorded as well, and we will send you a link in a follow-up email afterwards. Okay, it looks like we can get started here. I'm going to hand it over to Greg now.
Awesome, awesome. So let me start saying thank you again for inviting me back. I thought this was the second time, but I guess it is the third. So I guess I must be doing something right. Thanks again.
This is for sure. This is the most engaging webinars that we have. So that's the reason why you are invited more and more. And I would invite you every week if that's.
Yeah, I'm up for it, man. I'm up for it because the only thing I love talking about solar and storage more is about barbecue. And man, I got so good at barbecue during the pandemic. That was like my mental health break, right? Like it kept me sane while I was writing my book and while I was working. But let me share my screen here and let me know if you can see it.
Yeah, I can see it now.
Good. Okay. So we're going to talk about some things in my book that Eris and Peyton asked me to come back and talk about. And it's things that I see a lot in this industry that need to be addressed. Yeah. So yeah, there's me and my pretty face. Even my book, when I start out with the battery powered home, I start with common industry terms because it's so important for all of us to be on the same page. And I even poke fun at myself. I'm like, really, dude? Like we're going to start with definitions like we're in kindergarten, but we have to because people use the wrong terminology. And Eris, I'm going to pick on you just a little bit. One of the most common things that people misuse is the word panel when they're talking about modules, right? Solar panels heat water. They started out way back in the day, long before solar electric hit the market. And the guys that were installing solar thermal, when they jumped over to solar PV, they just kept calling them panels because they were blue and they were up on the roof. But it's a completely different thing, right? When you get an inverter and you connect that blue piece of glass to it, that's not a panel, that's a module. But it's so ingrained by a lot of people that it's hard to shake it, right? Like even the module manufacturers gave up. They're like, yeah, whatever, it's gonna call them panels because that seems to be the most pervasive terminology. And even in the 2020 national code cycle, the fire protection rule book, they even took panel out of the description because they gave up. But it's a very important distinction, right? And I'm going to talk about some other terminology as well, but it's like calling an alligator a crocodile, right? Like go to Louisiana and say, wow, look at that croc down there. They're going to think you're crazy, right? Or confusing weather with climate. Yeah, that's a big thing now with climate change, but people confuse the localized weather with climate change. People they confuse champagne with sparkling wine. That's a big no-no, right? And something near and dear to my heart, they confuse something like barbecue with grilling, right? Barbecue is low and slow, man. You put a 12-pound brisket on there, 250 degrees. It's taking you 12 to 14 hours to cook that thing. That's barbecue. If you're turning on your gas grill and doing burgers, that's grilling, okay? So let's get going here with some more of these terms, make sense of it. Here's a big one that I see is power versus energy. And the way that people misuse this or these two words is very common. Like, hey, I just installed a 20 kilowatt battery. Like, wow, 20 kilowatts. That, man, you must be running a lot of stuff in your house. And they're like, well, no, I needed like a big battery to run it for a long time. And it's like, oh, okay, you don't mean kilowatts, you mean kilowatt hours. So let's break down a little bit of what we're doing here, okay? And I'm going to just stop my video to save some bandwidth on this end because I see me being kind of choppy. So let's take a look at a really popular analogy for power versus energy. Here we have a bottle of water being poured into a glass. The spout opening is analogous to power. And the size of that water bottle is your energy or the size of your battery bank. Yeah. So if you're using a big Gatorade bottle that has a huge opening, the fluid is going to come out of that big opening a lot faster than if you're using like one of those old school ketchup squeezer bottles, right? We're just like, squirting it out. And so we can look at the opening as power or how much water that we can deliver. But we have this reservoir of water, or what we would call energy, which depending on how big that opening is, it's going to take a long time to fill up that glass, or it's going to take a short time to fill up that glass. Okay, so let's take a look. Power. And I'm not going to get really geeky into this stuff. And I don't get geeky in my book because people like dude, I don't care that there's 6.24 trillion or quadrillion electrons passing a point in 1 second. Like, I don't care about that. Just tell me what it means. Yeah. So power is a rate at which energy is transferred in a circuit, as far as what we're talking about electrical terms. Yeah. And here we have the humble 60-watt light bulb. And in electrical terminology, power is measured in watts, and we see it. And over here, you see the little W right here. That's watts. Okay. And we can measure watts by taking voltage and multiplying that by the current. And this ends up being a fairly easy exercise, because the voltage in our home is 120 volts or it's 240. But all of our appliances that you plug in the wall with a 2 or 3 prong receptacle, that's 120 volts. If you have that big round Gumby plug, like for your dryer or your electric stove, that's 240 volts. That's a different topic. Okay, so that's 60-watt light bulb. We get that by taking the 120 volts in our home and we multiply that by 0.5 amps. Or we could take, if we just shift that formula around, voltage divided by power is current. Okay, so a lot of different things we can do there, but that's power. It's measured in watts. Now, and Era's talked about PV inverters, I'm going to use products that are found on Renvu's website. Okay, everything that you see in this presentation comes from their website. Okay, I just wanted to give them that courtesy, but more so that you know that what I'm talking about is real. PV inverter power is variable throughout the day. And we see we have a 3,000 watt inverter. We have a 7,600 watt Fronius inverter. Those are the two numbers that are stamped on the nameplate on the sides of these two inverters. That is the maximum amount of power that PV inverter can provide, regardless of how many solar modules or how big the array is connected to it. Okay, so the higher the power, the more powerful the device. So if we take our humble 60-watt light bulb, this 3,000 watt inverter, well, the numbers work out pretty easy there. That 3,000 watt inverter, if it was putting out 3,000 watts at the peak of the day, then we could power 50 light bulbs. Yeah. A 7,600 watt inverter, well, the numbers aren't so easy there, but what would that be? That'd be about 125 light bulbs, give or take. Yeah. So higher the power, the more light bulbs we can power. But that is a variable amount of power throughout the day. Now we contrast that with battery inverters, which are connected to a battery. Those devices are continuous. So the nameplate of power on the side of these battery inverters is continuous. In other words, as long as that bottle of water has liquid in it, they can put out 5,000 watts or 9,000 watts on this solar model. Okay, so it is continuous. Higher power means you can run more loads. More loads. Okay, now I don't get any delusions of grandeur here. I have some big loads on here. I have an air conditioner and I have a pool pump. Two very common loads that people want to put on their AC electrical panel to be able to run when the grids go down. And we'll talk more about this here in a minute. But the more power you have, the more power your inverters have, the more loads you can run. Now, let's get to energy. This is the electrical meter that's on the side of your house from the utility. It's measuring the energy you consume. Okay, and energy is the power you consume or generate if you have solar or wind. It's the power consumed or generated over time. And while we cannot directly measure energy, we can measure the work that it does. And this work is defined in a lot of different ways. Okay, when you're on a treadmill and you're working out, the work that you do is measured in calories. The work an air conditioner does is measured in BTUs. And then we also have joules. But what we're concerned with in the solar and battery industry is the watt hour. That is the unit of measurement for energy. And so there are a lot of variations of a watt hour. And it turns from watt hours into kilowatt hours pretty quick. And that, when you look at your utility bill, that is how the energy is expressed on your utility bill. It's in kilowatt hours. So, well, what is a kilowatt hour? Well, it's 1 watt used for 1,000 hours. And I tried to find a 1 watt load, but I can't even do it. Like even like something that is off when it has a remote control, even though that device is off, it's not really off, right? Because that red light means it's waiting for the remote to tell it to turn back on. Even that's like 5 watts, right? Like for your DVR player. But something more relatable, it's either 1 watt for 1,000 hours, or it could be 1,000 watts for 1 hour. The utility company, your battery bank, doesn't care which one of these it is, because it's using this measurement of kilowatt hour. So our little 60 watt light bulb would have to stay on for 16.66 hours to reach 1 kilowatt hour. Yeah, so that's real easy. The 1 kilowatt hour would actually be 1,000 watt hours. 1,000 divided by 60 is 16.66. The watt variable would cancel each other out, and we're left with the H for hours. Yeah, it's that easy. So let's make this a little more relatable using one of my favorite foods, lasagna. Now, like I said before, you are charged by how much energy that you consume, not the power that you use for residential. Now, in commercial applications, oh, guess what? Utility companies not only charge you for how much energy you use, but also the peak power that you hit during the day. They're so generous, aren't they? But let's take a look at a little toaster oven here with some lasagna. Now, that toaster oven, this is pretty common. Excuse me. Toaster ovens can need 1,200 watts to operate. And if we ran that toaster oven for 1 hour to cook this nice thick pan of lasagna, then we will have consumed 1,200 watt hours, or 1.2 kilowatt hours. If you're paying 15 cents a kilowatt hour, and look on your utility bill very carefully, you'll see it. Matter of fact, there might even be 2 or 3 or 4 different rates by which you're charged. But we'll keep it simple here. Okay, 1.2 kilowatt hours times 15 cents per kilowatt hour is 18 cents. So it cost me 18 cents to run that toaster oven for 1 hour. Well worth it, by the way. That is money well spent. But now let's use this kilowatt hour into something, more relatable, into batteries. Yeah. So what does this mean for energy storage systems? And an ESS is comprised of more than just the battery. It's the battery inverter. It's the battery management system. It's the balance of system gear that goes along with it, like an automatic transfer switch, the communications. It's also the PV inverter. and all the modules up on the roof and all the other stuff that goes along with it. That's an energy storage system. So more loads mean you need more power to run those loads. However, if you're using more power, that means you're using more energy. And if you think about your phone, and I use this analogy a lot, when you charge up your phone, what determines how long your battery lasts? Yeah, a lot of things, right? Are you talking on the phone? How many apps do you have on in the background? Are you playing a game on the phone? The more things you have running, the faster your phone goes down. Also, the age of your phone matters, right? How many of you buy a new phone and you're like, dang, man, I didn't charge this thing in 2 days. And then 2 years later, you have to keep the thing plugged in all the time. And there's so many variables to this, and there's so much fun to talk about. All right. Now, I want everybody to participate in this one. Okay, so Ares will probably, let's monitor the chat because this really isn't a question. But I'm sure the good people at Renvu have asked their customers this exact question. What would you like to back up in your home during a power outage? And what do you think the homeowners say? What is the number one answer? Oh man, the answers are already coming in. What's the number one? Oh man, you guys are awesome, man. I love engaging crowds. I don't know, like I know there's people that register and then they're going to look, at the recording later, but this is so cool that there are so many people on right now. Oh my gosh. Yeah, and you guys are getting it. You're getting it. The number one answer, everything. Of course it's everything. We don't want to have to change our lifestyle when the grid goes down. Come on, man. Let's party it up. Turn that hot tub on. Let's go. So let's explore that a little bit. Awesome. Man, you guys are awesome. So let's do a case study. And this is my house. This is my house. I have a 5100 20-watt array. I have 16 Jinko 320-watt modules up there. You can tell that the wildfires here in California have dirtied them up a little bit, but I'm not brave enough to go on my roof and squirt them down and wash them off. You can see I've got a Sunny Boy SMA 5,000-watt TL inverter hanging on the wall. Matter of fact, it's right behind me on the other side of the wall. And I also have a 10 kilowatt hour lithium ion battery. Okay, so let's see what it would take if I wanted to back up my entire home. Now, I'll turn my camera back on here when we're on the Q&A, but behind me is a backup panel. And this panel has a lot of names. And here we can get into some other terminology that people confuse. Okay, this is a backup panel, essential load panel, protected load panel. Another term that people use incorrectly when referring to this is a critical load panel. That is a no-no word. Critical loads are completely different by National Electric Code standards. And I know this is just like people calling a module a panel. They call a backup panel a critical load panel. But let me tell you a quick story. The company that I previously was with did nothing but battery systems. And an installer was going to sell our system to this homeowner. And he told the homeowner, yeah, we're going to put in a critical load center. And we're going to put 6 or 7 circuits on there, no problem. And then it came time to test the system. So when they turned off the grid power to watch the house light back up, well, that particular battery system took 30 seconds to bring the lights back on. And that homeowner flipped. He was freaking pissed. And he went right to the installer's face. It was like, you told me this was a critical load center. That's supposed to turn, that is immediately supposed to switch over within milliseconds, let alone 30 seconds. Now, this homeowner was in the medical industry, and his mother lived with him with life support equipment. That is a critical load. Life support systems, emergency egress lightings, bank servers, things like that. Okay, your jacuzzi, however much you love it, is not a critical load. So what this installer had to do was install an uninterruptible power supply, or UPS, to cover the 30 seconds that it took for the battery system to switch over and start providing power. That was a $3,500 adder out of that installer's pocket because he didn't use the right term. Okay, so I find that I can sit up here and bleat all I want about using the right terminology, and people are like, yeah, Greg, we get it. But when I start throwing money in there, then people start listening. Okay, so my backup panel does contain all the circuits in my house. Okay, here is my battery breaker that feeds this panel. Here is the solar breaker. Now, the only two exceptions that I left on the main panel are my air conditioner, which takes 3,500 watts to run, and my electric dryer, which is 3,000 watts. Okay, everything else is in my house on this sub panel. Now, let's take a look. I went through the last 3 years of my data, and I found the largest spike of power that I ever used, and it's right here. Okay, 5.13 kilowatts. Okay, so let's take that. Now, remember, that's 5.13 kilowatts, not including my dryer or my 3-ton air conditioner. So let's take a look. Oh, something else I want to point out. I do not have enough sun during the day to charge my batteries. Now, I'm working on a time of use schedule, so I want to make sure that my batteries are full by 5, because that's when my window starts. And you can see that we have 5 o'clock to about maybe 9 o'clock. And then my battery's at 5% state of charge, and I'm done. I'm done for the day. Okay. And again, this does not include if I run the dryer or if I have my poor air conditioner on in the summertime. So since I don't have enough sun, I actually have to sip off the grid to make sure that my batteries are charged before this high peak time hits me. And that's all I'm worried about, is just covering that 4 or 5 hour window. But now let's take a look if I wanted to do a whole home scenario, because that's what everybody wants to do. They want to back everything up. Okay, fine. This is a Solarc inverter. It's on Renvu's website, like I said. It has an output of 9,000 watts. But if I look at how many watts my dryer and my air conditioner take, along with that spike that I had, I need 11.5 kilowatts, or 11,500 watts total. If everything was on in the house, okay, and now this is old school off-grid mentality, okay, and I would challenge you that even when the grid goes out, the majority of people, right, that may only be 55 or 60%, even when they have a renewable energy source or they have a backup generator, they're not running around turning everything on in their house. Okay, if they are, then they're not, using their energy wisely. But let's say I'm one of those people. I don't care. I want worst case scenario. I'm throwing a party. It's Christmas dinner. Everything's going. I'm not grilling outside because it's cold, and I've got a whole house full of people. Okay, fine. Let's do that. So we need a battery inverter or 2 to handle this load. So we can see here, 9,000 watts is not sufficient. Okie dokie, then you're going to need 2 of them. Or what else can we do? Turn that stuff off. live a little more frugally. Don't put large loads on your backup panel. Or if you're doing a whole home backup, then get some load controllers to help you with that. And there's a lot of cool stuff. Lumen Smart Panel, Span Panel. They're actual main panels that are connected to your phone app that you can program to turn on and off based on a lot of different parameters. Now, that totally changes the name of the game. But that's a $4,000 adder. And they have to rewire all the circuits in your home to that new panel. Not too many people bite on that. So another option, instead of my backup panel with all those circuits on, I can use something even smaller. I am a big fan of the Pick 6, right? Just like the lottery. Pick 6 circuits in your home that you want to back up. And those are usually the kitchen, the living room, the master bedroom, garage, and then something else in your house, right? Outdoor lighting, things like that. Okay. Now, your energy consumption is seasonal. In the summer months, I consume about 2,000 kilowatt hours a month. And if you multiply that by 0.18, you can tell roughly how much I pay every month. Now, let's break that down into battery terminology. That's 66 kilowatt hours a day. My 5,000 watt solar system here outside Sacramento can produce about 9,000 kilowatt. Oh, I'm sorry. That's a year, about 25 kilowatt hours a day. Okay. I use 66. I can produce 25. Okay. It doesn't take a rocket scientist to figure out that something's not going to work. Now, conversely, in the wintertime, 400 kilowatt hours a month consumption, which is 13 kilowatt hours a day. But when you're doing whole home backup, which one of these two numbers are you going to plan for? The smaller one or the bigger one? Yeah, that's rhetorical because we all know it's going to be the one on the left. It's going to be the big one. Okay, so let's go with that. And here, again, right off the Renvu website, we're going to need 2 inverters. We're going to need, you can multiply this by 4 if you want, because you're going to need 10 of these batteries, and you're going to need 2 strings of them. Now, I use the Simplify battery calculator to figure this out. Solarc also has a battery system calculator that I used. Now, these are rough numbers. Okay, these are rough. But you would need 2 of these. You would need 2 of these per inverter. So you're actually looking at times 4 here. And then you're going to need 32 340 watt modules times 2 because we have 2 inverters. Oh, man. Who's doing the math in their head right now? Huh? Let's take a look. Again, this is rough sizing. Roughing it, we're looking at a little over $78,000. But we're not done. We're just going to use some average industry numbers. We're going to add 10% for labor. We're going to add another 10% for balance of system components. That's all the conduit and the wire and all that stuff. And we get to just a little over $94,000. Now, don't quote me on this. This is, again, rough sizing. The people at Renvu will help you narrow this down into something more precise. But, you know, this is pretty close. Yeah. And I'm sure Eras and the salespeople at Renvu would love to sell you a $94,000 battery system, huh? What do you think, Eras?
I'm starting to count the money over here, yeah.
Absolutely. Absolutely. So, ladies and gentlemen, you want to do whole home backup, you're going to pay. And I talk about this in my book. It gets a little more complicated than this because you'll need multiple inverters. You'll need multiple battery banks. Not every battery inverter or battery supplier can accommodate that. Yeah? Or if they can, you're not going to have one backup panel. You're going to have 2 or 3 backup panels. That adds even more cost and complexity to the system. Some battery inverters can accommodate a backup generator directly connected to it. Some can't. Backup generators are a great idea because if you live in the Northeast where you have a lot of storms, or Peyton and I and Eris were talking before the webinar, and she was 2 weeks without power in Iowa, because of storms. Okay, so backup generators can be extremely helpful in charging the battery if you don't have enough sun. Not every battery inverter can accommodate that. So there's so many variables. Matter of fact, my book has been out for 9 months now, and it's doing very well. And I thank everybody. I thank the industry for the support. But what has really taken off is my little side gig of consulting. And this is what I'm doing for people. They send me their information. They're like, look, dude, just be straight with me because you were straight in the book. Just tell me what I need. Tell me if I'm being overcharged for this or if I'm doing it right. And a lot of off-gridders are coming to me for help. And I'm like, dude, okay, dude, I'll help you. But the book was grid-tied lithium storage. But okay, let's do it up. So I tell everybody this because I want you to understand that this is what you're in for. And I would rather have you get this information now than get sticker shock and back out and run away when Eras or the other salespeople come from Renvu to talk to you about these systems. Okay? All right. Now, let's talk about another industry terms. There are 2 kinds of power, and I already talked about them. Okay? There's continuous power. So when you turn on this light bulb, it's going to pull 60 watts until you turn it off. There's also what we call surge or startup. On almost every battery inverter spec sheet, they call it maximum power. And I'll get into that here in a second. But here's a great example of a load that people want on their backup panel, usually in a rural area, that has surge. Okay, that's a submersible pump. Another example would be an air conditioner, a pool pump, a sump pump if you have a basement. Okay, anything that rotates or reciprocates needs to overcome its at-rest position. Okay, and the best way I can talk about this is when you turn your car on, your tachometer is at 0. And when you turn the ignition on, that needle flies way up, maybe to 6,000 or 7,000 RPM, and then it rests down into 1,000, which is the idle speed. These loads do the same thing. They need a lot of current to overcome their at-rest position, and then they slow down to the running speed. Okay. Now, the battery inverter that you have must be able to handle that surge. And as I already said, it's on their spec sheets what their rated power is. So let's take a look. And Eris mentioned this inverter, Solus. Okay, let's look at this inverter. I screenshotted this right off of their spec sheet. Okay, AC output in backup mode. Okay, so the grid is out. It can have, or it has a 6,000 watt continuous output. Okay, we'll just put in 25 amps. That's what that is. And I put that current in there because when you look at the nameplates of these big compressors and motors and things like that, they give their startup spec in current. This inverter, its surge power, which they call maximum apparent power, is 7,000 watts for 1.2 seconds. Okay, that is 29 amps. Okay, everybody with me? All right, so let's take a typical surge rating of an air conditioner. Unfortunately, there is no typical, but it's a range, 65 to 80 amps. 65 to 80 amps. That's a long way from 29 amps. So if we take 65 divided by 29 amps, you would need 2 battery inverters just to start that inverter. Okay. Worst case scenario, 80 divided by 29 is 2.75, which means we would need 3 of these battery inverters just to start that air conditioner. Now, there's some other ways that you can get around that. Okay, you can cheat. You can cheat a little bit, and you can use what's called a soft start kit. And a soft start kit's been used in the off-grid world for forever. And it's just a box full of capacitors, and it reduces that surge current on the battery inverter. Okay. But you'll need one for each of these large devices, and they're anywhere from $300 to $500, depending on how big a one you need. Okay, and I talk about this in my book. All right, duty cycle is something we need to talk about because that's the interval of the runtime. Okay, and I don't know, and you probably know this. Okay, your air conditioner does not stay on 24/7, although when the temperature is 113 here in, outside Sacramento, my poor 12-year-old air conditioner is on like 20 hours a day. It's ridiculous. I really need to swap that out. But you probably hear your refrigerator kick on and off during the day as well. All right. So duty cycle is that interval. All right. So here we see a bunch of spikes. This was my previous screenshot that I took of my system, my battery, my PV. And you see all these spikes down here? That is my son's portable air conditioner that's in his room. He gets horrible ventilation in there. It's like 80, 85 degrees in that room during the summertime. And I'm just like, dude, let's just get you one of these portable ACs. It's the one that's on wheels. The output goes to the window. And he keeps, I have to keep on because he keeps trying to turn that thing down to like 65. I'm like, all right, dude, like 73. Let's keep it at 73. But in the middle of the night, you see these spikes. Every 15 minutes, that little air conditioner turns on. And it's pulling, 1.2 kilowatts. Yeah. But only for that short amount of time. So I hooked a meter up to it. It's called a kilowatt. And you can find them on Amazon. And you just plug your appliance into it, plug the kilowatt meter into the wall. And I did that for my son in his room just for this air conditioner. And that air conditioner pulled 7.6 kilowatt hours. Anybody remember how big my battery bank is? Who remembers how big my battery is? Type it in chat. Oh, yeah, there we go. All right, just making sure you're still with me. 10 kilowatt hours. 10 kilowatt hours and almost, 7 kilowatt hours is going into the battery. It's being taken out of the battery just for this stupid AC. Yeah. Yeah, I know. It's crazy. But let's take a look. The refrigerator. I wish I had a nice one like this, especially with that meat there in the bottom, man. Oh, man, that looks good. When you're sizing your home, refrigerators run about 6 hours a day. And what I tell people is just use 2 kilowatt hours a day. Yeah, 2 kilowatt hours a day. That's a good estimate. So there we go. We got 7.6 kilowatt hours for my son's little portable air conditioner, and 2 kilowatt hours for my refrigerator. That basically takes up my battery system for the day. Yep, thank you very much. Now, we have some different load center choices, and I've already alluded to this. The main panel is that big breaker box next to your meter, or your meter's attached to it, has all the loads in your house. You can do that, or you can do an essential load panel, backup panel, protected load panel, where you can just put 6 circuits on there. This one has 8, but yeah. So I'm a big fan of essential load panels, okay, because it forces you to watch your energy consumption. Now, like I said, you could replace your main panel with a SPAN, SPAN, or a Lumen smart panel, LUMIN. But again, that costs, another, about $4,000. But man, all these breakers that are replaced are controllable by your phone. You can program them. Like, it is so cool. It is so cool. Now, let's take a quick look at an ESS layout. Okay, now, they may look a little bit different, but they all have these same common components. I work for a company called Tygo. We make these little optimizer things that go on the back of the modules to harvest more energy. And we recently got into the energy storage business with our new product here. Okay. And you can just replace most of what you see here with the equipment on Renvu's website, and would be the exact same thing. Okay. So we come in from the grid to the meter to the main panel into an automatic transfer switch. And from there, we go to the essential load panel, protected load panel, whatever you want to call it. We also go into the inverter, which is connected to the battery, which is also connected to the solar array. This is called a hybrid inverter. It's a hybrid inverter because it has a battery connection and a PV array connection. When the grid goes out, the automatic transfer switch flips over and isolates all the power that we create when the grid is out from going into the grid. You have to have this mechanism in some form or another. Okay, because if you generally, when the grid is up and you have excess solar, it just goes into the grid, right? And it goes through the meter, and you're compensated in some way or another for the excess solar that you send into the grid. Well, that is against the law to do when the grid is out. So we do not let any excess solar go into the grid. Instead, we divert it mechanically with this ATS. So the sun comes in the inverter, we charge the battery, and then it goes, makes a U-turn, and we power the loads in the house. Yeah, easy peasy, right? So let me ask one more question. The grid is out. We're powering these loads. How long can we power those loads? How long can we power those loads? There's something else I kind of poke fun at in my book. It's a 2-word answer. So that's easy, right? And this will go for any battery system out there. The answer is, it depends. Depends on a lot of stuff, right? Now, let's get into, and I don't mean to rush, but there's just some good stuff I want to talk about. Feel free to email me or Renvu later. I'll be happy to talk about it. But I do want to get into battery chemistries. And there are 2 main chemistries on the market right now. We have NMC, and you can see the chemical designation underneath. And then we also have LFP, lithium iron phosphate. And when you look at these 2 batteries, they look the same. Yeah, they look the same. They may even have the same numbers on them, but they may have different diameters. One may be a little taller than the other one. But what's on the inside is really what makes up the difference. Okay. And so Tesla and LG Chem are the only people that use NMC in these battery cells. Now, these are battery cells, okay? Tesla uses the same battery cell in the Powerwall as they use in their car. Matter of fact, in the car, they use 7,000 of these battery cells. They're just all connected together. Isn't that amazing? It's so cool to me. And they just do the same thing in their batteries. Okay, so Tesla, LG Chem use NMC. Everybody else uses LFP. And I find it interesting that Tesla announced that they were going to switch over to LFP. And there's a very good reason for that. Now, when you start looking at the pros and cons of these two battery chemistries, most of the stuff is really only interesting to engineers. Nobody cares about it. Oh, well, this one's got more energy density. And oh, well, that one's got more power density. And oh, well, this one, like, nobody cares about that. Okay. As a matter of fact, I know this for a fact that you can have a technologically superior product in every way, but people will go with the other one because it's cheaper. Yeah. And there's many examples of this throughout history. You know, VHS versus Beta, right? The Beta was far superior than VHS tapes, but VH took off. VHS tapes took off, right? So, yeah, I don't talk about these specs very much because people don't really care. But there is one spec that everybody cares about, that everybody talks about, that makes it in the news, which is why Elon Musk is considering shifting the NMC chemistry over to LFP, and that is battery safety. Huge thing. A lot of news articles hit the rags, the industry media after a big battery fire in Arizona. It was a utility scale. If you search, you can, well, shoot, everybody knows the Galaxy Note 7, right? Those things were catching on fire. You see videos of those. You can see and you can find electric vehicle fires. They're out there. Yeah. Now, when you look at these battery cells, what you're going to find are these battery puncture test videos. Okay. And the previous company I worked for had a video where they put a nail through an NMC battery and then they put one through an LFP battery. Okay. The LFP battery didn't do anything. It smoked. The NMC battery exploded. Okay. Oh, see, NMC batteries are dangerous. That is not the right message. And it's an unfair test. And if you scrub the internet long enough, you can find these nail puncture tests for both chemistries. Okay, so the nail puncture test to me is a non sequitur argument. I don't even want to entertain it because both will ignite. NFPA makes no distinction between chemistries in the National Electric Code for safety anyway. So it just doesn't matter to me. Okay. Now, the good news is that ESS battery fires, along with electric vehicle fires, are very rare. They don't happen very often. And when they do, they get a lot of hoopla around it. But luckily, there are some things that you can do to ensure that you'll have a safe system. Number one, use a good quality battery. And this really only applies if you're going off on some no-name brand or you're trying to like solder your own battery bank together. So you bought a bunch of, $1.50 batteries from some Chinese company and you're going to make your own battery. Okay. Most of the time you don't have to worry about it. A good battery management system will also help prevent these, what the industry calls thermal events, right? Call them whatever you want. It's a freaking fire. Okay. But a good battery management system will help mitigate that. But above all, a properly installed system. This is what we have control over, is the properly installed system. Oh yeah, look at this. 2 EV chargers. How about that? There's some big loads. Now, and evolving codes and standards are also helping with battery safety. Okay, so there are some code changes. Like, for example, you cannot put an energy storage system in a livable space. So there's a lot of marketing material out there where you'll see a battery in a living room. And my former company was guilty about it. Now, there's probably no danger at all, but the code does not think it like that. Okay, so you cannot put batteries in a livable space. You can put them in a garage. That's fine. And now there's even talk in California that you cannot have them in a garage. You have to have them outside. So the codes, they're getting dicey. And every time we have a fire, it gets worse, right? Now, I don't agree with making energy storage systems outdoor only installations. I think that's asinine, because you're going to tell me that I have to put my 10 kilowatt hour battery system outside, but yet I can park my dream electric vehicle, the Rivian, with a 135 kilowatt hour battery bank in my garage, and that's okay. I can park my Model S in the garage, and that's okay, when it has a battery system 10 times bigger than what I have. That's asinine. That makes no sense. All right. Let's talk lastly about some AGM batteries, because Renvu also sells this, but this is a common question. They're like, well, what about lead acid? Dude, we've been using lead acid batteries for over 100 years. Like, what's up? Well, let's talk about that. Not everybody wants to make the switch over to lithium, and there are some advantages and disadvantages to both. Okay, everybody's flocking to lithium because the price has come down thanks to Elon Musk and the electric vehicle manufacturers. The price, has gone down tremendously. Okay? But there are a lot of applications for AGM batteries. Okay, they can deliver high amounts of current. They're maintenance free, which means it's not like your grandpa's battery where you got to keep putting water in them. However, the one ding that lead acid batteries had, this actually is considered a flooded lead acid battery, which is different. But typically, you do not want to discharge these batteries below 50%. So what that means is you need twice the battery bank size from what you calculated so that you only discharge to 50%. Okay. Now, let's take a look at this. This is, Renvu sells this battery. This is a cycle versus depth of discharge chart that's on the battery spec sheet. You will not find this for lithium ion batteries, and I'll tell you why here in a minute. So if we look at the 50% area, and you can see the deeper you discharge these batteries, the fewer cycles you get. Okay, now what we're looking at here is depth of discharge, or how much energy you have used in the battery. How much you've used, that's depth of discharge. The inverse of depth of discharge is state of charge. That is what your cell phone tells you. That number at the top is the state of charge, or how much you have left. Okay, so for this battery at 50% depth of discharge, you'll get 1,750 cycles. Okay, and a cycle is counted a lot differently in lead acid batteries than they are in lithium. If you drop this battery, this lead acid, this AGM battery down 20% and fill it back up, that is a cycle. But if you do that on a lithium battery, if you only went down 20% on your lithium ion battery bank and then charged it back up, that would be 1/5 of a cycle. So lithium ion batteries don't count a cycle until you've had a charge discharge of 100%. Huge difference. Okay, so 1,750, if you cycled it once a day, once a day. Then 1750, what is that? 1750 cycles divided by one cycle. That divided by, 365 is 4.79 years. Okay. So less than 5 years. If you cycle it to 50% only every day, you will get 4.79 years out of that battery, and then you get to buy another one. Now, you could make the argument, well, Greg, I'm doing grid-tied battery backup, man. My grid only goes down once or twice a year, maybe for 2 hours. Okay, well, now you're looking at, 15 years for this battery bank, right? So there's so many things we have to talk about. And so when we contrast that with lithium, the typical lithium battery bank is going to give you 6,000 to 10,000 cycles. And you don't stop at 50, you can go 90 down to 100%. Yeah, so there's a lot of benefit to lithium. And the reason lithium has taken off in the last 5 years is because the price has come down. But there's a lot of things like, here you go. I do a lot of consulting work for preppers, and they almost always use lead acid batteries or valve regulated gel AGM batteries, because those batteries do not require a battery management system. They don't require electronics other than what's in the battery inverter, to operate, right? So in case of an EMP blast, as long as the battery inverter electronics are protected, the batteries will be fine, right? You can't say the same thing for lithium batteries because they have a battery management system circuit and control board inside them. So you would have to put a Faraday cage around the entire battery bank if you're using lithium. You can tell I've done this a couple times. All right. So just some minor things, right, to think about. So what I have seen are what we call these 2-hour battery systems. They're becoming very common. And there are people that are a little more level-headed that realize, okay, I don't need to back up my entire home, but if I did, it's probably not going to be, more than 2 hours. Okay, so the energy storage system would cover that 2-hour outage, worst case scenario, at night with no solar support. Okay, so the cost comes down significantly, and they don't take up as much room in their garage for the product. All right. Now, and this Peyton, we were talking about this. She said, yeah, dude, we were out of power for like 2 weeks. Those guys in California, just north of me, when PG&E shut their power down and went from, oh, yeah, it's only going to be a 2-day outage, turned into 10 days. Okay. Matter of fact, the very beginning of my book has a story in it. That is a real story. Okay. That's a real story that happened. I changed the names because I didn't want to tell on anybody. But they were in the middle of a 10-day outage, and they decided on the second day to have a jacuzzi party. And I'm just going to leave that as a cliffhanger, and you can either read my book or figure out what happened next. Okay. So that's it for me. I will hang around and field as many questions as you can. I do have a website. I am on YouTube, and much to my 15-year-old daughter's horror, I am on TikTok. But even she's warmed up to that. She's even like watching my videos. Cool thing about TikTok is you only have to hear me talk for like 3 minutes max, right? All right. So let's look. Wow, look at all the chat stuff, man. That is awesome. Awesome. So let's look at some questions. And Eris, if I miss some, or if you find one that's a little more interesting, just let me know. So, wow. Okay. So right off the bat, there are a lot of application specific questions. And I cannot get into the specifics of each one of these during this thing. Like it would take too long. But Eras or Peyton, if you want to send me the questions, and if you guys are comfortable like with the emailing, I will be more than happy to do that. Or you can ask this question on my website, right? Just go to snarkysolar.com. I have a way for you to contact me there. I'll be happy to do it. So Mark is asking about battery voltage. Like his battery voltage is right around 48 volts, which is typical. It can be higher or lower than that. But he says when he makes a pot of coffee, the voltage drops to 47 volts and then goes back up to 48 when the coffee pot is turned off. Is this harmful to the battery bank? No, it's not at all. As a matter of fact, that is very common. That's what it's supposed to do, right? So when coffee makers have a resistive load in it, right? So anytime you have a heating element, that's a resistive load, right? Lights are resistive. And so that takes a lot of energy. So yeah, you would expect the voltage to go down. Yeah, absolutely. That's going to happen on everything. And a lot of applications. Do you have a hybrid inverter? Yep, that's the one I had. And so Nedixon's asking about a DC coupled system, which is what I showed in my example there. Okay, there's also AC coupled systems, which are very popular if you have an existing solar system and you want to add batteries later. Now, not only will you have to add batteries, you'll have to add a battery inverter. And this is something else that you need to look at. You need to make sure that the new battery inverter can be used in an AC coupled solution. Okay, I know we didn't get into that, but that is something that you need to look for. All right. Okay. Here we go. What do you say to people that want to do whole home backup that's too small, but it's cost effective, and they want to manually turn off larger loads like the AC, the hot tub, etc.? That's from anonymous attendee. Anonymous, that is an absolutely fantastic question. And I get that all the time. So what they're asking is, okay, fine. They want to do whole home, but they will manage the loads. They will turn the breakers off to the big loads, or they just won't turn them on. Okay, they will manage their consumption. Man, that is probably an 80-20, right? Almost everything can be divvied up into this 80-20 rule, right? 20% of the homeowners that say they will do that actually do it. The other 80%, the first time the power goes out, forget to do it. And when they go in the dark 2 hours later, then they remember, oh yeah, we got to start turning stuff off. Yep. So absolutely, if you want to do a whole home, but the system is not small to accommodate everything, which is okay, right? Because you're not going to have everything on at the same time anyway. So if you want to do that, then I say full speed ahead. That falls into one complete section of my book where I talk about customer expectation management. And I know that it sounds kind of salesy, okay? But I didn't write this book for salespeople. As a matter of fact, I reworded the book description that my publisher gave because it just sounded too salesy. And people were doing reviews on Amazon. They were like, man, this sounded like a salesperson book, but I'm a homeowner and I learned a lot. So yeah, if you want to learn what the pros know, this is it. Yeah. And I talk about that specific scenario where it's totally fine to do a whole home backup as long as those people know what the implications are. As long as you tell them, hey, we're doing a whole home backup, your battery and everything is kind of small, right, to do everything. But if you manage your loads, you'll be fine. If you forget and turn your air conditioner on and your jacuzzi and you want to start arc welding, well, then you're going to get 15 minutes of whole home backup. Yeah. All right, Michael, I build homes in upstate New York. People want backup for freezer, refrigerator, heat pump, and lighting. People don't want to hear a generator wailing in the background. Dude, yes. And that, Michael, you are doing it right. Freezer, right, to keep that deer meat cold. I got mine right here. Refrigerator on to keep the beer cold. A heat pump to stay warm. Some lighting that you can see. And then plugging in your phone, right? That's really all people need. Yeah. Be comfortable, have your beer, have your food stay fresh, and be connected to the world during a power outage. And that's it. That ends up being such a smaller system that you'll get much more mileage out of, that you will be much more happier with. I guarantee you. All right. So then we have some specific things, right? Ed's asking, well, my well pump surge is 12 kilowatts. What would work with that? Yeah. So to find that, we would have to go look for specific inverters that could handle 12 kilowatts. Okay. And so just doing a quick calculation, that's 50 amps. Okay. So you would have to find a battery inverter that can provide 50 amps of surge at 240, right? Off the top of my head, I do know a couple of them. The Solarc is one of them. Like, that thing is beefy. It really is. So it just becomes an exercise of looking at spec sheets. Yeah. But if you find a battery inverter that you like, but it only gives you 25 amps of output, or 6 kilowatts, well, then you have to buy 2 of them. Yeah. So don't make that mistake of just looking for one device that can put all of it out, because that number may be very, very short. Maybe only 1 or 2, maybe 3 things on the market that could do that in one battery inverter. But then we also have that trick of using a soft start kit. All right. Oh yeah, here we go. Staying on grid without batteries. Will the equipment allow load changes? This system will supplement the grid. And that's an interesting question. So staying on grid without batteries, will the equipment allow load changes in excess of their rating or what is available from PV? I understand. Okay, that's a great question, Chuck. So what Chuck is asking is, okay, I have a solar system. Let's say we have that 7,600 watt Fronius, okay, 7,600 watts. And then he's asking, so I turn something on, or the loads in my house exceed what that inverter can put out. Okay, so what would happen in grid tied? The grid would supplement the difference between what your solar can produce and what you are consuming in your home. Yep. But it will only do that during the daylight hours. All right. And Erez, let me know when I'm getting too long on time, because, man, there are so many great questions. Another one here, Richard Brown. Is anyone doing iron air yet? Now, there are so many battery technologies out there, and there are some really good ones. Unfortunately, until they are accepted, until the early adopters jump in on them, make them more ready available, and drive the cost down of these new battery technologies, it's just not going to happen. Okay, right now you've got lithium and lead acid, unless you are willing to shell out a lot of money for these other technologies. Okay, David, does your book cover how to size a battery backup for offsetting peak charge times? Yes, it does. As a matter of fact, that is the easiest thing to do. That is the easiest thing to size for, are these high peak areas. Yep, but there are some caveats, like always, but I do get into detail on that. Oh man, there are so many good systems. Okay, here's a good one. Is it better to use a UPS or get a fast enough switch to switch loads from off-grid whole home to city? Yeah, that's another it depends, right? So a UPS, if you're talking about your whole home, that's going to be very expensive. Yeah, the reason that one guy had to get a UPS was just to cover that small amount of time because he messed up and called it, a critical load panel, and that's not going to cut life support systems. All right. Oh, is your book available in audio? Man, I bounced that around so many times and just decided no, I wouldn't do it. Mainly because it's a very expensive adder. And I thought, well, maybe I could do it, but then nobody wants to hear a redneck go on for like 3 hours about batteries, right? All right. Okay. Here's a good one. Can you discuss the time required to charge a generic 10 kilowatt LFP battery? So I think you meant to say 10 kilowatt hours. And here's a great answer. Matter of fact, some of you in this chat probably already know the answer to this. How long will it take to charge a 10 kilowatt hour battery? Depends. Yeah. Depends on how many loads you have on while you're trying to charge. But let me give you an answer that's not so smart alecky, right? Let's say that you have a 5,000 watt inverter and a 10 kilowatt hour battery bank. So if you had 5,000 watts of continuous power from that inverter, which you wouldn't, then it would take 2 hours. Yeah. In generally speaking, a 5,000 watt inverter can charge a 10 kilowatt hour battery during the day with modest loads on in about 4 hours, maybe 5, depending on cloud cover and all that. Yeah. Okay. Wow, man, so many good ones. In your diagram system with the main panel ATS inverter, is the backup panel always energized? And is it the ATS that manages the power that comes from the grid or the battery? In other words, the backup panel circuits are not a duplicate of the main panel. Again, from an anonymous attendee, yes, that is an incredibly observant question. So the backup panel is always energized. Okay, it always has power. Either the grid is trickling into it, or the battery or the solar is feeding that panel. Absolutely. And then when the grid goes out, it's only sunshine and batteries that feeds that backup panel. Absolutely. All right. Earlier you referred to a system that took 30 seconds to switch over. Was that a specific transfer switch? Yeah, and I get that. You're like, man, I don't want to use that one. So luckily, that's an older system. Okay, 30 seconds is absurdly long, and that company has reduced that down to 2 seconds, which seems to be standard for most energy storage systems. So 2 seconds. Okay, that is an extremely long time in electrical movement. Okay, 2 seconds will not keep your computer on. The lights will flicker. So you should probably, and this is what I recommend, you should probably put a little UPS, right, a little one, on your computer system, right? I have one on my desk. I've got my computer plugged into it. Yep. So that's something else that I don't see a lot of manufacturers put on their spec sheets. That's called switch over time, right? Or bridging time. And I don't see very many battery manufacturers that talk about that. Probably because, if it's 2 seconds, that's not really something to brag about, right? There are some that will flip right over. Like you won't even see the lights blink. And I've heard people that didn't even know their power was out until their neighbor came over and said, "Hey man, can I charge my phone?" Yeah, that's how good some of them are. All right. Are you considering doing a course on Udemy or Coursera? No, that's a good question. I have not thought about, well, actually, that's not true. I've thought about doing courses like this on, there's a popular one in our industry called Heat Spring. There's just so many good courses out there already. I didn't know if I just wanted to be, another small fish in the big ocean of training out there. I don't know. Maybe that's something I should look into. But yeah, thanks for asking.
Okay. Do you want to take that last one?
Yes. Thank you, Eris. So I'll answer this last question because it has to do with something very, very important. Matter of fact, I even answered or talked about this specific application on a LinkedIn comment that I made where somebody was posting, how do you keep the lights on when a grid goes out and all you have is solar, right? Because you probably already know if you only have a solar system and the grid goes down, it doesn't work. You need batteries. But the article mentioned a generator. And the way that they included a generator in the write-up made it sound like you could just add a generator to your existing solar system and you wouldn't have to worry about all this battery garbage. Okay, that is a very, I'm not going to say dangerous thing to do because it's not dangerous. It's a very dumb thing to do. Yeah. So somebody is asking, assuming there's no sun, no grid, no battery power, can a generator be integrated seamlessly into the system? Again, I'm so sorry to tell you that is a huge, it depends. Okay. And you never, and I'll tell you this, you never, ever install a generator with a PV system on the load side of a generator because the excess PV could eventually make it into the generator and blow the regulator board and your generator is done. I get specifically into this in my book as well. So you need some very sophisticated controls if you just want to use like a portable generator. But I will end on some battery inverter manufacturers have a terminal for a direct connection for a generator. Yep.
Including, solar for sure.
Oh, but absolutely.
This is a ESS or storage inverter. Okay. You actually managed to answer all the questions, and there were a lot. That was an amazing webinar. We'll probably push it in our LinkedIn and YouTube, and everybody will get a recording and a slide deck to their emails after this, probably in the following 2 days while we are editing a little bit. Greg, as usual, thanks a lot. I personally enjoyed it. So I'm sure that all these participants, and we have almost 200 people here, enjoyed it too. And yeah, see you next time.
Awesome. That is so cool. Thank you, everybody, for watching. Really appreciate it. We'll see you next time.
Thanks, Greg.